Hello, my dear students. Myself, Debi Prasad sir, welcomes to you all to the chemistry class. Today, I will explain you about the rest part of the chapter matter. Diffusion. You might have remembered that when ink is poured into a glass of water, it starts spreading till it reaches all parts of the water. The particles of the ink move between the particles of water till all the ink is evenly distributed. Diffusion is the natural movement of particles from a region of high concentration to one of low concentration. It brings about even distribution of the particles. Diffusion proves that matter exists as particles. If matter did not exist as particles, then the blue ink would not spread throughout the water in the glass but would remain concentrated in one place. Now, Brownian motion. A botanist, Robert Brown, was studying pollen grains mixed with water. Under a microscope, Brown observed that the pollen grains were constantly moving although the water was not disturbed. This is because the water molecules are continuously moving, hitting against each other and pushing them in all possible directions. This random movement of particles is known as Brownian motion. Now, law of conservation of mass. It states that matter can neither be created nor destroyed by chemical reactions or physical transformations. According to this law, the mass of the products in a chemical reaction must be equal to the mass of the reactants. Consider the following equation: A plus B gives rise to C plus D. In the above equation, A and B are the reactants and C and D are known as the products. Now, the mass of the reactants is equal to mass of A plus mass of B, and mass of the products is equal to mass of C plus mass of D. According to the law of conservation of mass, total mass of the reactants is always equal to the total mass of the products. Now, example of combustion of magnesium. When a piece of magnesium wire is burnt in air, a white powdery substance, namely magnesium oxide, is formed. The mass of the magnesium oxide formed is found to be more than the mass of the magnesium burnt. This is because we need to take into account the mass of oxygen as one of the reactants. Then magnesium plus oxygen gives rise to magnesium oxide. Mass of the reactants is equal to the sum of the mass of magnesium and that of oxygen, and the mass of the products is equal to the mass of the magnesium oxide formed. Now, absolute scale of temperature. This scale was invented by the British scientist and engineer Lord Kelvin. It measures the temperature in Kelvin degree or Kelvin, the temperature at which the molecular motion ceases and average kinetic energy of the molecules becomes zero is called absolute zero. On most thermometers, zero is just a mark. Temperatures can fall far below 0 degree centigrade. The lowest possible temperature is minus 273 degrees Celsius or absolute zero. In actual practice, before the temperature of minus 273 degrees Celsius is reached, a gas liquefies and is no longer a gas but a liquid. The temperature at which the volume of a gas would theoretically be reduced to zero gives the lowest possible temperature that can be reached and is called absolute zero. A temperature scale with absolute zero as the starting point is called the absolute scale or the Kelvin scale. All temperatures on the Kelvin scale are positive. In order to convert the Celsius to Kelvin, degree Celsius plus 273 is made. The temperature is expressed in Kelvin but no degree symbol is attached to it. My dear students, I hope that you have understood the contents of this video. The rest part of this chapter matter you will learn in my next video. Thank you for watching and learning from this video.